Next reaction are amides. How to make an amide? We have a lot of ways. Acid chloride, anhydride, ester, carboxylic acid. Take all these, heat it up with RNH2, and you can get an amide. Okay? What can you do with amides? Well, if you add acid and water, you can hydrolyze it back to the carboxylic acid and the amine. The other thing is if you add LAH, you can form the amine. You get rid of the carbonyl. Okay? Notice this reaction. That's really how the only way you can, break down amides. So that's why you're not supposed to get acid on yourself. What happens when you get acid? Even base. You can also add sodium hydroxide here as well, if you wanted to. But if you get base on you or acid, why do we tell you to wear your goggles? Well, your eyes are made of proteins. So if you get acid in there, it starts hydrolyzing all of the amides inside of your eyeball. That is not a good thing, as you can, it's pretty obvious that's not a good thing. Okay? So what you want to do is, the whole point is that amides really only react with acid and base, a little bit with LAH. If you get LAH on you, it will probably burn, but it's not going to do that much damage on you. But acid and base, those break down your skin. That's what acid will do. Finally, 10.11 is nitriles. So we already saw how to make a nitrile by an SN2 reaction earlier in this chapter. Nitriles, there's a few things you can do with them. One, if you add acid and water, you can hydrolyze it into the carboxylic acid, which again we saw at the beginning of this chapter. You can add an equivalent of Grignard. So I'm going to put R this time. Let's put X. It doesn't matter what you use. And you can make a ketone. Technically, you can add another equivalent of Grignard if you wanted to. So you can either add one equivalent or two equivalents and get the ketone. Just like how we saw with the esters. That'd be an OH, R, R. Sorry, that's a single bond right there. Lastly, another thing is LAH. You can reduce nitriles, and it gives you the amine. CH2 and H2. Alright, so that's what you can do with nitriles. We are going to skip the remainder of the chapter, which is 10.12 and 10.13. There's something extra I wanted to talk about. I wanted to go over the mechanism again. In particular, let me just show you a generic reaction. Let's say we're going to take an acid chloride, and let's say we're going to react it with, let's say, an alcohol. Okay, remember this makes the ester. I want to go over this mechanism just to kind of show you plus HCl. Okay, acid chlorides are very reactive. Again, this chlorine is very partial positive. This carbon is very partial positive because it's attached to a chlorine and an oxygen, and it has a pi bond. Okay, so this oxygen is going to come in, add there, and this pi bond is going to kick up to form your tetrahedral intermediate. Okay. Then this pi bond reforms and kicks out your chlorine. And then your Cl minus comes by and plucks off that hydrogen to form your ester and your hydrochloric acid. Every reaction in this chapter is the same. This is how this reacts. This is how this works. Basically, it's you have a nucleophile attack. You break a pi bond to form the tetrahedral intermediate. The electrons pop down and kick out your leaving group.